Good afternoon. I'm Dennis Burrell. I'm with Ventev. I'm the product planner, and I come up with the products that we're going to bring out to the marketplace. So I'm doing due diligence with people like you, hear your feedback as far as what you would like to see or some of the challenges that you've come across in your deployments and questions that you have from your customers, and take some of those and try to implement those into products. And then also what's going on in the Wi-Fi world, the protocols, the different strategies, and then working with the Wi-Fi Alliance and those types of groups as well to come up with products based on the direction that Wi-Fi is going. Right now we're going to talk about large public venues and high density. So what is a high density network? You guys know this, but we're just going through some of these things. Networks to convert coverage-oriented traditional Wi-Fi to capacity-oriented Wi-Fi to meet the demands of high concentrations of Wi-Fi users. Some of the areas that this is prevalent in is university and corporate campuses, stadiums and arenas, big push for stadiums now, convention centers, airports, city centers, auditoriums, and manufacturing facilities. So when providing high density coverage to a stadium, a combination of following solutions can be taken. So we look at providing Wi-Fi in a stadium in 4 different areas. We call what we call a top-down solutions, where we have antennas mounted to the overhangs in the stadiums, front to back. So when we want coverage in the front down in the bowl area, we have solutions that are mounted to the guardrail that separates the field from the stands. Then we have what we call side to side, and these are antennas mounted on handrails between the sections, mostly and predominantly down in the lower bowl. And then a bottom up approach, and that's antennas mounted under the seats. Recently saw an article where it's talking about a lot of the stadiums are going to under the seat deployments of their Wi-Fi. So from top-down high-density solution, we offer antennas of various gain and beamwidth models, numerous port and polarization options. Those antennas can be mounted on flat surfaces or pole or mass mount. We provide articulation both in vertical and horizontal directions, and also the radomes can be painted. The picture that we have there is one of our mounting solutions that we'll discuss a little later. It's called our co-locating mount, where we can mount the access point and the antenna in one plane, and then the antenna has articulation via the mount so that you can stir your beam on your coverage to fine-tune your coverage. From a front to back high density solution, like I said earlier, it brings the Wi-Fi to users in the front rows, small form factor. The antenna is housed within a rugged enclosure. And with this antenna design, we have a mount in it that can vary adjust the antenna from plus or minus 20 degrees, and it's ADA compliant. And those are a couple of actual deployments that we have done. This one in particular right here, that's University of Nebraska Stadium, where we did the Wi-Fi for their stadium. For our bottom-up solution, we have small form factor enclosures where we can mount the access point and also small antennas. The antennas on this particular Cisco access point are what we call our Bantam antennas. They're about 2 inches tall, provide about 3 dB of gain. They're dual band. And we deployed this in Dodger Stadium, and a version of this where we have the enclosure and the antenna only in San Francisco Giant Park. Right now we're currently working with a company, one of our companies that we work with now. We're working on a version of this where they want articulation within a 8x4 enclosure. So we're working on the design for them. So now that you can have the antenna in and you actually have a plus or minus 20 degrees of articulation within that small form factor enclosure.
Is there a mount bracket included with this enclosure, like a T-rail mount or something that's
Yes,
inside?
so we have if you can see below there, there's a mounting plate to mount the access point on. And then we also came up with the design, if you look over there where it says installs on the concrete and runoff, we came up with that mount as well, so it's at an angle so that when it rains or when they power wash, the water can go down behind it or below it.
Is there one of the reasons I asked is I ran into this with an Aruba product where we installed it, and in order to mount it to the mounting plate, we had to use the Aruba mounting bracket, and then we had to put the AP, and then we had to put the
T-bar.
Yeah, and then we had to put the antennas in there, and it ended up exceeding that 4-inch limitation. So there's another manufacturer has one with an integrated T-bar inside it that you can just slip on. Is that an option that you guys have?
Yeah, so we have a T-bar mount that we can put in there as well.
Instead of the plate?
Yes.
Okay, cool.
And then side-by-side high density solution. These are unobtrusive. The one that we have right here we call our handrail antenna. And that's a small form factor, as you can see, about 7 by 8.7 by 3. It has a 4-port antenna in it, vertical and horizontally polarized, dual band, ADA compliant, and it's right or left facing option. So ADA mandates that if you put anything on the handrails, you have to have at least 2.5 inches of space so that someone can get their hand on the top or on the bottom or when they're grabbing it. So we came up with this design. This is also the University of Nebraska. We came where we first did this design for them, and then that's Toyota Stadium, a soccer field down in San Antonio, Texas. When we first came out with this design, it was a 3 dBi version, but since then we've released a 6 dBi version as well. And we say that it's right or left facing because depending on which side of the stadium or the stands you want to light up, that's the way you would direct the antenna. You wouldn't be able to tell it. It sits specifically in this orientation, but we mark the antennas down where the Ventev logo is so that you'll know which is right facing and which is left facing.
So that's a directional antenna?
Yes, it's a directional antenna.
Okay.
How do you get away with proximity to people and the FCC guidelines in terms of putting them here?
So good question. So for this, the FCC mandates that you have to be 20 centimeters away. So this is far enough away from the first user that you don't have to do any FCC. But for under the seat enclosures, and we'll discuss some other things later, that if you're within 20 centimeters, then you have to do specific absorption rate testing with that antenna.
But I mean, people walking by, people actually reaching up and grabbing, the handrail are definitely within 20 centimeters of that antenna.
Right, and
It's not continual.
It's momentary. It's not continuous, so it's quite different than sitting on it or having the phone up to your head.
And what's the pattern on that?
So the pattern is about 100 degrees in the azimuth and about 60 degrees in elevation. And so the new design, the 3 dB design is a little, the narrow beam width's about 90 and 65 degrees.
Are you including a pigtail leads out on that, or are you just having jacks on there that you need to run
Right.
a last cable up to? I mean, because that's always been the problem with handrail mounts of any type, whether it's front or side like that is, well, it's great, I can put my antenna there. Where's that access point going?
So good question. So this particular antenna has 15-foot pigtails, and when you put the antenna onto the rail, you drill a hole. It goes through and under the concrete to the access point. The access point is either under the concrete or to up under the seats.
Wow.
So it'll come down. It'll either go under to an access point, or it'll go down to the base and come out via conduit over to the access point, which is in an enclosure.
What type of cable is that for 15-foot pigtail?
It's LMR, low loss cable, 195.
195.
Yeah. And
Cool.
so So the good question, because now you're saying, okay, the cable is thick, but then what about the connector? So for this particular design, although it can be used on any access point, the cable connectors are either SMA or RPSMA because of the diameter to get them through the conduit once it goes through. And then if you're using a Cisco access point, you're using adapters.
It's like you guys thought about that.
Yes. So this is our new solution that'll be coming out around July 2016. So it's another handrail design side to side, and it mounts on handrails that have a diameter of 1.67 to 2 inches. This one can support 2 access points and 2 antennas. So now the one that I previously showed was only 1 antenna. So we begin a lot of requests to co-locate the access points and the antennas because one, some of the stadiums don't want to go under the seat or below the concrete for the access points. So they want to only want to just bring up the cat cable to the access points, and they want everything co-located in one housing. So we came up with this design. This one is also ADA compliant as well. So there's currently a similar product out on the market, and I can show you what our differences are. So this enclosure needs to be NEMA 4 rated because you don't want any water or anything getting in it and the power washing or anything. But also, like we said, there are 2 antennas. Now, the difference between ours and what's currently out there is although the access points are side by side, the antennas are back to back instead of side by side. And that saves some more space. So by small form factor, although those look like large numbers, compared to what's currently on the market, this is small form factor compared to that because we have the antennas back to back instead of side to side, which would take up more real estate. 16 screws to seal the enclosure. Minimum unused space, no sharp edges. Corrugated design provides additional impact protection. By corrugated design, as you can see, you have what looks like a Wi-Fi symbol. That's what we call a corrugated design. That adds rigidity to the enclosure. And then it fits Cisco's new 2566D4 M antenna or an equivalent antenna. Now, one of the questions that has come up, or one of the questions you guys may be thinking, okay, you're putting these antennas back to back. What about the radiation patterns and the performance of the antennas because you have them back to back instead of beside each other? So what we did was that we went and we simulated the antennas back to back. So we have a equivalent model of the D4M that I'll be speaking about later. But what we did was we took them and we put them back to back on a metal plate, 9.5 inches by 9.5 inches square, and we put them back to back, and we simulated feeding one of the antennas, and that's S11. So you see the return loss of the antenna resonant at 2.5 and also at 5 gig. And then what we did was we wanted to see what the isolation was between the ports. So we measured we did a simulation to measure the isolation between the ports of the same antenna, which is your S21, S31, and S41. And as you can see, we're greater than about 30 dB of isolation between the ports. So then the next thing we wanted to do was measure the isolation between the antenna port that we excited to the antenna ports on the back side of the metal plate. And those are S51, X61, 71, and 81. And as you can see, the isolation is still well below almost 60 dB. So what this shows is that there's no interference between the 2 antennas being back to back, because if there was, that isolation wouldn't be as good. That isolation would be high. And then when you looked at your radiation patterns, you would see a lot of ripple in your patterns, meaning that they're interfering with each other. Yes?
So you're adding a metal plate, or are you using the metal plate that's already mounted on the...
We're using the metal plate that we're mounting the access points to.
So they're adding a metal plate.
Yeah, so
Yes.
how thick is that metal plate?
That metal plate, do you know, it's probably about a quarter of an inch.
It's just
Is it less, eighth of an inch?
Oh, okay. Quarter inch, that's a big chunk of metal.
not quarter.
Well,
Yeah.
So how much does the whole thing weigh when it's fully loaded? The APs are multiple pounds a piece.
APs are what, 3 pounds, so 6 pounds. Antennas are, so it's 10, 12 pounds, maybe 15 pounds, maybe
Oh,
20
so you can
pounds.
still one-hand it when you're mounting it?
Yeah,
You hold it with one hand and screw
you
it.
can do that, yeah.
And so I mentioned earlier, so then a product that we're coming out with is a 4-port directional antenna. And what it is, it's 50% smaller than the Cisco 2566D4M. It's dual band, 4-port polarization diversity. So you have 2 vertically polarized antennas, 2 horizontally polarized antennas, 6 dBi gain, designed for indoor-outdoor environments, and it also ships with a dual-axis articulating mount. So this was the antenna that we modeled in the previous slide for the to look at the isolation and the effects of being back-to-back. We've done some extensive testing on this antenna, and we're very excited about this model that'll be coming out soon.
Is there any, I mean, are you losing anything when you go to these smaller form factors? Because obviously when people, you're an antenna guy.
Right.
When you come up with a design for an antenna, you want to have so much space for your grounding planes and everything on these. And, we look at the Gilaroos, the Graylings, the other antennas that, Cisco and other folks have put together. And yeah, they're massive. And they're, where I was told, well, they have to be massive because of the grounding plane or because of how we want to get the pattern
Spacing
out
between the
there.
elements or whatever.
Yeah. What do we lose going down to smaller sizes? Do we lose anything, or is it?
So there are cases where you can lose some things, right? So in the past, I think now we're more stringent and more meticulous with our designs. So you go through your typical gain formulas when you go through your design, taking into account the efficiency of the antenna, the aperture size, and the wavelength that you design at to get your radiating element. So now you have your radiating element, you want to co-locate that element with other elements to get, say, a 4-port or a 3-port antenna. So that's where your spacing comes in. Typically, we do spacing of half a wavelength between the radiating elements in order so that you don't get interference or you don't get mutual coupling between them to affect the pattern. So to do pattern shaping, don't mess up the pattern and the isolation between the ports. So once we go through that, then we go through some stringent numerical analysis designs. Okay, what are the things that we can do to shrink it smaller but yet keep the performance? The feed network, making sure the feed network is radiating efficiently. In some instances, depending on the gain of the antenna, if it's a lower gain antenna, you can mess with the for instance, with a dipole, we can bend the arms of the dipole that'll affect the beam width slightly in the pattern slightly, but not detrimental to the design. So those are all the types of things that we go through, and we just do trade-offs, and then we benchmark. For instance, we benchmark this antenna against the Cisco antenna. So we send them out to a third-party lab, do testing to see where we are, and then we fine-tune. So for us, just based on the way the industry is and what Cisco has in the marketplace, and as well as Aruba, if we're going to come out with an antenna, we want to make sure that it's as good, or if not better, than what they currently have.
So a question on that, right? And I won't name names. Lee already got mad at me. But there's a vendor, and I hope they're listening. There's a vendor that has antennas spec'd in with their piece of equipment. And I said, you know what? I can get a different antenna. I can put another one in there. I want it to work for an LPV deployment. It's a little bit of a different form factor. There's a big cost difference, which every penny counts when you're trying to win a big deal. And they came back to me and they said, absolutely not. We won't support your design. We won't support anything unless your antenna is, blessed by our team in order to make that happen. That sucked. Like that, there was nothing cool about that. And it gave me a little bit of heartburn when dealing with that vendor, because it wasn't just about me making a decision because I thought it was great. It was because that was going to win a deal versus losing a deal. Are you guys doing anything with these vendors, whether, no matter who they are, and I won't name names, but no matter who they are you doing anything with them to say, hey, we have this antenna, can you put it through your process so that it can be blessed by you guys? Or am I still stuck in the situation where I go, well, if I use this, then they won't approve a deployment?
So it's
And I know it's not really up to you.
No, exactly.
It's up to them, but
Right.
is there anything that you guys are doing to go, hey guys, come on, man. I mean, we're trying here.
Yeah,
Especially specifically for LPV.
So it's kind of for us it's kind of a catch-22 with some of the vendors, right? In the sense that we work with them on some other products, enclosures, and those types of things. And in the instances where we have niche products as far as antennas,
Like the handrail antenna. Perfect example.
they'll work with us. But then on some of the more standard stuff, then we get that butting heads type of thing. So it tends to be on a case-by-case basis.
Well, I would love to see it because so far everything I've seen that you guys are doing, it's great. There's a lot of ingenuity there and problem solving to get something done. But unfortunately, not to be Debbie Downer, but if the vendor, if the AP manufacturer turns around and says, oh, that's great, but I'm not going to certify your deployment because you're not using our brand antennas, that takes all the wind out of the sail of the VAR, the integrator.
Yeah, and unfortunately, that's a hurdle that we face sometimes, and we're still
sure you
trying
do.
to work with them to get over that as well.
Cool.